Welcome to This Explainer, where we're going to completely strip away all that sci-fi Hollywood hype and uncover the actual history and key concepts of artificial intelligence. So no killer robots today, just the fascinating, grounded reality of how these systems actually work. Let's get right into it. Today's agenda is basically your roadmap to understanding AI. We're going to cover, is it actually AI? Defining the technology, AI versus basic automation, the AI hierarchy, demystifying the Turing test, and finally, history and AI winters.
All right, Section 1. Is it actually AI? Let's kick things off by testing your current understanding.
I want you to think about a few everyday tools you probably use all the time and ask yourself, which of these are truly powered by artificial intelligence and which are just, basic programming? We have Netflix suggesting your next binge watch, Excel calculating your expenses, and your thermostat turning the heat on at 7 a.m. Take just a second to lock your answers in. Okay, let's see how you did. Things like an Excel sum formula or your standard home thermostat fall firmly into the not AI category. Why? Because they rely on very rigid, pre-programmed rules. A thermostat just operates on a set schedule. It doesn't actually learn anything about you. On the flip side, platforms like Netflix, Gmail, and Amazon absolutely are AI. They use machine learning and collaborative filtering, which is just a fancy way of saying they find patterns in user behavior to adapt and learn from millions of data points, all without a human explicitly telling them what to do next.
Moving to Section 2, Defining Artificial Intelligence. Now that we've busted some of those myths, let's look at how the experts actually define this tech.
What's really wild here is the date. We so often think of AI as this purely modern 21st century invention, right? But this foundational quote comes from John McCarthy way back in 1956. He defined it as the science and engineering of making intelligent machines. He literally coined the term at the Dartmouth Conference, which officially birthed artificial intelligence as a legitimate academic discipline. Now, to actually achieve McCarthy's vision without just explicitly programming every single step, AI systems focus on 5 core goals. First up is reasoning, which means solving problems by applying logic. Second is learning, so improving performance through experience and data. Third is perception, like interpreting sensory input, think computer vision or speech recognition. Fourth is language, understanding and generating human text. And fifth is planning and action, setting goals and executing them, kind of like an autonomous robot navigating a warehouse. So AI isn't just one magic trick, it's the active pursuit of these very specific capabilities.
Section 3. AI versus basic automation. So what makes AI fundamentally different from the automated software we've been using for decades?
A brilliant way to understand this distinction is by looking at a spam email filter. Under the old automation approach, a programmer had to sit there and manually write fixed rules. Something like, if the email contains the words "win money" in all caps, mark it as spam. The problem with that is it's super rigid, it's easily bypassed by spammers, and it requires constant manual updating. The AI approach, however, analyzes millions of emails to automatically learn common spam patterns, suspicious sender behaviors, and weird language structures. It adapts on the fly. Basic automation blindly follows instructions, whereas AI learns, handles uncertainty, and makes dynamic decisions.
That brings us to Section 4, the AI hierarchy explained. Let's map out these different branches of AI you're constantly hearing about. You hear all these buzzwords thrown around constantly, right? Machine learning, deep learning, generative AI, but it's absolutely crucial to understand that these aren't competing technologies. They're actually nested subsets. Think of them like Russian nesting dolls, narrowing down from the broad umbrella of artificial intelligence all the way down to highly specific capabilities.
Breaking that down a bit further, inside that massive, broad field of AI, we have machine learning, which powers things like predictive analytics by automatically learning patterns from data. Go a layer deeper, and we find deep learning. This uses advanced neural networks with tons of layers to tackle seriously complex tasks, stuff like facial recognition or self-driving cars. And finally, nestled right at the very center is generative AI. This is the subset that creates entirely new content from scratch, whether that's text, images, audio, or code, rather than just analyzing existing data. It's the engine driving massive, game-changing tools like ChatGPT.
All right, Section 5, Demystifying the Turing test. We're going to do a little time travel back to the mid-20th century to look at a very famous benchmark.
Alan Turing's brilliant 1950 concept was originally called the imitation game. The setup is simple. You have a human interrogator communicating entirely via text through a structural wall. On the other side of that wall, hidden away, are a human and a machine. The whole test was designed to evaluate if a machine can produce text-based responses that are so natural they are completely indistinguishable from the humans.
But here's the thing, we need to be very precise about what this test actually measures. The Turing test is, at its core, a test of conversational deception. If the human interrogator is fooled, the machine passes. Period. What it is definitively not is a test of true conscious intelligence. Modern large language models like GPT-4 can easily pass text-based variants of this test while still hallucinating basic facts and making incredibly simple logic errors. Why? Because they simulate human conversation incredibly well, but they're doing the whole shebang without any true underlying understanding of what they're saying.
Which leads us to our final section, Section 6, History and AI Winters. Let's contextualize our current AI boom by looking at the rather turbulent timeline that got us here. From Alan Turing proposing his test back in 1950 to the official birth of the field at Dartmouth in '56, AI history has been a total roller coaster. We've seen massive, historic leaps, like IBM's Deep Blue defeating the world chess champion Garry Kasparov in 1997. Then, the deep learning revolution truly kicked into high gear around 2012, eventually leading us to 2022, when ChatGPT launched and hit 100 million users in a matter of months. But do you notice the massive gaps in that timeline? Progress in AI has not been a smooth, straight upward line. It's been defined by massive leaps separated by incredibly long, painful periods of stagnation.
Those historical periods of stagnation and collapse are known as AI winters, and understanding why they happened is crucial if we want to avoid repeating the mistakes of the past. The first major winter hit in the 1970s. Early systems worked great on simple toy problems but completely failed on real-world complexity. It was a problem known as a combinatorial explosion. Basically, the number of possible outcomes grew way too fast for 1970s computers to actually calculate. Researchers had drastically overpromised, and when they underdelivered, massive funding cuts followed. The second AI winter happened in the late 80s when early expert systems collapsed. They required enormous, expensive, hand-coded knowledge bases that were just too brittle to maintain. Simply put, early rule-based AI couldn't scale.
Which leaves us right here, right now, in the middle of the biggest AI boom in human history, driven by algorithms and neural networks that actually can scale. But considering the harsh lessons of those past AI winters and the massive, fever-pitch hype surrounding today's generative models, we have to leave you with this vital question. Are we properly managing our AI expectations today by realistically scoping out problems and understanding the text limitations, or are we just blindly heading for another AI winter? It's something every single business leader and tech enthusiast needs to seriously consider. Thanks so much for joining me on this explainer, and I hope this foundational roadmap serves you well.